Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Stability of canonical resonance structures depends on factors such as 1. Minimizing formal charges, 2. Placing negative charge on more electronegative atoms, 3. Placing positive charge on less electronegative atoms, 4. Maximizing the number of bonds, octet completion, and 5. Avoiding charge separation when possible. Moving on to the next step. Analyze structure I. In structure I, the oxygen bears a positive formal charge, O+, and the carbon-oxygen bond is a double bond. Oxygen is highly electronegative, so placing a positive charge on oxygen is unfavorable, but there is still a double bond present. More bonds is equal to more stable. The nitrogen lone pair can donate into the system, providing some stabilization. Moving on to the next step. Analyze structure 3. In structure 3, the nitrogen bears a positive formal charge, N+, and the carbon-nitrogen bond is a double bond. Nitrogen is less electronegative than oxygen, so placing the positive charge on nitrogen is more favorable than placing it on oxygen. Also, the C is equal to N double bond with the OH group present means the oxygen lone pairs can stabilize the adjacent positive charge through resonance donation. This structure is more stable than I because positive charge on N, less electronegative, is better than positive charge on O, more electronegative. Wait, actually placing plus on less electronegative atom is more stable. N is less electronegative than O, so N plus is more stable than O plus. However, structure I has the positive charge on oxygen with a double bond to carbon, like a protonated carbonyl, which is a recognized resonance contributor. Structure 3 has C is equal to N plus with O, which places plus on N and benefits from the oxygen lone pair donation. Overall, 3 is more stable than I because N plus is preferred over O plus. And for the final step, analyze structure 2. In structure 2, the carbon itself bears a positive formal charge, C+, making it a carbocation. Carbon bearing a positive charge with no pi bond is least stable among these three because A. Carbon is less electronegative than N or O, but a carbocation lacks the stabilization of a double bond, B. There is no pi bond to distribute the charge, and C. A full positive charge on carbon adjacent to N and O without resonance delocalization through a double bond is highly destabilizing compared to structures with pi bonds. Establish the order. Structure 3. Positive charge on N, less electronegative, C is equal to N double bond present, O can donate, most stable. Structure I. Positive charge on O, more electronegative than N, C is equal to O plus double bond present, less stable than 3 but has a pi bond. Structure 2. Positive charge on C, carbocation, no pi bond stabilization, least stable. Thus the stability order is 3I2, which corresponds to option B. Why other options fail? A. I2 3, incorrect, places 3 as least stable, but N plus in a pi system is more stable than O plus. C. I3 2, incorrect, O plus less stable than N plus in resonance structures. D. To 3I, incorrect, carbocation 2 is least stable, not most stable. Therefore, the correct answer is B. Therefore, the correct answer is option B.